Okay, this is for those of you who are kind of have figured out how to do reactions, and everyone else as well. But what I've got here is I'm demonstrating how when you solve for reactions and put all your vectors in, that the sum of the moments and the sum of the forces equals 0 no matter what you do with your coordinate system. So what I've got here is just a couple of applied forces here. All right, and then I've calculated the reactions by, of course, summing the moments about point A for the applied forces and calculating a reactive force at B, and then doing the same thing at B. And so you come up here, that's on the left. On the right you see the forces. In other words, this is the x and the y of the radial vector, and the force of the x and the y for this one here. So those correspond to that. And then the next line, push this over here to the side. The next line, I click on that, hit escape here. I click on that. That shows the next line. And we have the reaction force there on a different layer. That's the third line. And the reactive force there, a fourth line. And so we have the r sub x, r sub y, r sub z, f sub x, f sub y, f sub z, with z coming out of the board. The sum of the moments, or the moment of that force about point A. Point A being at this point the 0, 0 point. Same thing for the second force. This is the moment. You notice this reactive force here, right, is at 0, 0. It's going to have no moment about that force, so the moment there is 0. And then the same thing for the reaction, which I calculated over on the right. All that's said and good, all that's said and done, that's great. Now let's see what happens and why you need to keep each file in its own file. Each problem, at some point you really can't collect them together on one file. You need to use xref if you want to take these things and put them together. What I'm going to do right now is just move the entire system here, and I'll move it just up at 20 angle 90 degrees. And now when I hit a regen, and hit a regen over here, you'll see that all the moments have changed and all the typical radial vectors have changed, but the sum of the moments down here and the sum of the forces has not changed. That's essentially 0 for all intents and purposes. Let me go back. Move previous from here at 20 angle 270. If you haven't figured out how previous and last work, it's about time. So I'm going to hit regen. You notice I've got to regen both. Regen. It goes and recalculates them again. I'll go ahead this time, move it a little bit farther. Move cross at 100 angle 45. Regen. Regen. Look at all those numbers changing largely so. Move previous at 100 angle 225. Takes it back. Regen. Regen. Alright, so you can realize that's one thing you can go about. You can realize how important that understanding where that 0, 0 coordinate is. If you remember, one thing we've done in the past is move window, grab everything from the endpoint here to 0, 0, 0. I hit a regen now here and a regen here. You notice how the negatives become positive, and we've kind of shifted everything by 20 left or right. Once again, the forces, this is the forces, the x, the y, and the z, all continue to be 0, as does the moment. Now let me do an undo just on that one. Right, now let me show you how that can work for you. Let's say, however, you wanted to calculate at point D now what is the forces and the moments of the external forces. So you wanted to cut at point D. And if you cut at point D, really you replace that with a force in the y, the force in the x, in a moment. At this point, since you've gotten rid of those forces, if you hit regen and regen as well, you can actually sum up. We've got 1, 2, 3, 1, 2, 3 forces, and that one there is no longer there. Minus 17, the sum of the moments. Notice we haven't changed my coordinate system. I'm going to go undo here. Undo, 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 undo. I'm going to move this cross from the endpoint of there to 0, 0, 0. Notice in this case you can't move the coordinate system, you have to move the thing. So it's a little slippery slope, but because of the way the field command and data extraction works, you actually have to move your thing to there. And then if we go ahead and erase out, assuming we're doing a section, we want to know what are the internal forces at D. We do this and we hit a regen. And we click over here and we hit a regen. And we can see that the internal moment is going to be the sum of minus 17, the opposite of minus 17, minus 44, and 97. And we can see that the internal forces have to be, in effect, the opposite of what is there. So we can do undo here. Undo a few times. Undo a few times. Maybe we can do it again. This time we can move across everything here from the endpoint there to 0, 0, 0. And if we erase off this force and this force and hit a regen and hit a regen, we can see the calculation that the internal moment has to be the opposite of the sum of these. So that is a useful way, I think, to conceptualize how you can start using some of these programs and how you can then start to do this graphically and algebraically. So essentially what you're doing here is when you cut that, you're replacing it by a force in the x, a force in the y, and the moment. And if you look at this, obviously the moment is going to be turning to the right to resist this. And if you did it the other way, you can do the same. You can cut the other direction. Instead of getting rid of the two forces that are there, you can cut the other side of it. So we can get rid of that one, get rid of that one, hit a regen, and a regen, and you should get the same sum basically. So that's how, when you've laid out and put all your forces in the correct directions from the correct spots, how you can go about actually calculating internal forces and moments anywhere through a structure, whether the structure is a truss or a frame system like this. And it's kind of worthwhile when you think about how many different forces you can have applied on there. So I'll provide this file for you, hopefully, if I can remember to bring it in tomorrow. You do a bunch of undos here, get this thing back to 0, 0, which I think it is, regen. But you should be able to go ahead and set up the field command yourself. And if you look at this, I've got things on different layers. That's on a layer called force concentrated. These are on force reaction. And these, of course, were calculated by first and foremost calculating the reactions, though you can realize on this problem you could get the internal moment in C at C without ever calculating the reactions, but you would not then have had that internal check. So there's a number of those problems on the next problem set that I make it pretty simple for how you're going to calculate the internal moment. And in those, in fact, you do not necessarily need to start with solving for the reactions, though it is good practice for all. So once again, we've done over in this table is we've used the field command to define the start x, start y, and start z, the delta x, delta y, and delta z, and then here inside there we've actually calculated. Use the calculation, and these commands are not so great in AutoCAD, but they do work. They're not so great in the table command. So I'm going to save this, file, save, and then I'm going to print this out, and that'll be the last thing. You should experiment with this, those of you who have solved for the reactions. The rest of you need to get to this point where you can slide vectors, add vectors, check vectors, and then start using these tools. Not as a crutch, but as a way to kind of really put it in you so that the matrix algebra and the graphic algebra and the algebra all make sense and come together as you get ready for the workforce. Thanks for listening.